Okay, welcome back. We stopped a program, and I want to pick it up where I left off. So there's this cool command called foreground. Okay, FG and BG for background. So see the little one over there? Okay, that tells me that that's the. It's not the process ID number. It's a listing of all the processes that I've got dealing with. So if I want to say FG and then parentheses is, not parentheses. A percent sign basically tells me that this is something special. Remember how when we did the redirect, we had an and sign to make sure it was special, except this time it's a percent. I have no idea. What this is going to do, this is going to pick it up right where it left off, which is like an image bin. Okay, I'm going to hit Control C because I'm done with it. All right, so foreground command and background command, isn't that pretty cool? So I can start something in the background. Okay, so let's do this again. I'm going to do, let's do tree slash, and I'm going to mark that into tree.out. Now I think that's going to take a long time. So if I just did that, I'm probably just going to sit around and twiddle my thumbs waiting for the cursor to come back so I can get back to my prompt so I can do something else. That doesn't sound very efficient, does it? Perhaps I can start this guy and tell it to go in the background. Ooh, wouldn't that be cool? So start a process, but just go ahead and show me from the very beginning that it's in the background. I'm going to do this with an and sign. What that basically means is start this process, but immediately put it in the background so my prompt would come back. So boom, my prompt is back. I can now do something else. Now, is it running right now? Yeah. In fact, I can type status, and it's going to tell me, oh man, that thing was quick. Oh, sorry. Okay. I was trying to come up with a status command to tell you which one it is, but it looks like it's already finished. So that thing was quicker than I thought it was, doggone it. So remember, Control Z will put it in the background, okay? And then I can do FG for foreground. I can do background, that kind of stuff. If I've got multiple tasks going, I can put any one of them in the background. I can say, background %2, to put it in the background, that kind of stuff. So on page 118, they start talking about the signals that you send to processes. So the kill command, if I had, don't really have a process running right now. I mean, all I got is this. Hey, why don't we, that's pretty dumb. So I tell you what, I'm gonna do that tree command over, and I'm gonna hit Control Z. So I'm gonna do tree slash. Okay, I've got it stopped. Now I really don't want that guy anymore, so I'm gonna kill him off. In other words, instead of bringing him to the foreground and killing him, which seems kind of ridiculous, I'm just gonna kill him right where it is. So there's the kill command. Now what I could do is, since I'm using those special numbers, I'm gonna say kill %1, which means go to that guy and kill that guy. So that's pretty cool. Boom. And it's going to tell me that it killed him. Cool beans. So that's what the kill command. On table 10.4, good buddy. They talk about the common signal numbers that you can send. So a kill -2 is a very gentle reminder. A kill -2 is the same thing as Control C. That means stop what you're doing. A kill -15, which is the one if you don't give it a number, it's going to ask the machine very nicely. It's going to send a message to that process and say, "Hey man, your user don't want you around anymore. Would you please stop?" And most applications will adhere to that and say, "Okay, fine. If you guys want me to stop, I'll stop." But sometimes they don't. And so you have to use a kill -9. A kill -9 basically says, look, I don't want any of your shit. You're going down now. I mean, I'm not asking you pretty please. I'm telling you, you're going to have to stop. You're going to have to stop now. So kill 9 is the big boy. Okay, kind of makes sense? So how do you get the process ID of a running process? Well, I kind of sort of did PS, right? So, well, I don't have her running now, but so it gives me the process IDs that I can whack, right? So if I wanted to whack somebody else's, I would have to use like the AUX kind of guy, right? Okay, So the next section in this chapter is the shutdown command, and there's several of them. One is called shutdown. We've seen that. Shutdown now, 2 words. One of them is called reboot, to reboot your system. There's even one called power off, but to tell you the truth, that's basically the same thing as shutdown now. And there's one called halt. And if you look at that manual for halt, it has something kind of funny in it. I don't remember exactly. Oh well, this is okay. In the old manual, it said if the processor is on fire, use halt. In other words, halt is the fastest way to take the system all the way down. Now, apparently, the humor it's been removed from this. Doggone it! Halt the machine, regardless of which of the 3 commands are input. Okay, so the halt command basically says go down now. Power off is kind of straightforward, and reboot. Now, wait a minute. You mean any user can go in there and type halt, power off, and reboot and all that stuff without having to provide the user credentials like elevated? I don't have to do sudo shutdown now. Why is that? Because these commands have the set user ID bit turned on, which means when you evoke this command, it automatically assumes the owner, and the owner in this case is going to be root. So this is one of those cases where I do not have to use sudo shutdown now, because the shutdown command, when you type it, it automatically switches the user to the owner of the guy. Kind of cool, kind of scary, but kind of cool. Okay. All right, so let's move on to Chapter 11. So Chapter 11 is about the environment. I kind of mentioned that the shell is kind of everything, keep track of whatever the heck you're doing. Remember, like, for example, the current working directory is maintained by the shell, because only the shell knows where you are, right? Nobody else knows where you are. It's the shell that knows what directory you descended into. Kind of makes sense? So there's an awful lot of data that has to be stored in the shell. I mean, lots of data has to be stored there. So where's all this stuff stored? Well, there's a thing called environmental variables. And there's a thing called shared variables. There's a thing called aliases and functions, but that's not really relevant to the conversation just yet. If I say print env, this is going to show me all my environmental variables. It's going to, I'll tell you, let's just pipe it through less. So I've got, the first one is colors, ls colors, and this god-awful long thing, I don't know what the heck it all is. And there's one called less close. And there's one called lang. Now you may notice something, and this is a convention, not necessarily a factual thing, but everyone follows it. And that is, environmental variables are 99, 44, 100% time are in uppercase, the variable in uppercase. So home is capital H-O-M-E. Kind of makes sense? All right, so if I want to look at the contents of one, I would just say echo and then spell out like home, right? And that would tell me what that environmental variable is. Cool? Okay, so environmental variables are kind of sort of cool. Now, if I want to see everything, all the environmental variables plus like the scratch pad, which is what's called shell variables. Shell variables are like, what are you doing right now, and that kind of stuff. And then aliases and functions, which we have not talked about at all. There's another one called set, and it shows you everything. Unfortunately, it's a lot, so I'm definitely going to have to pipe that through less. So it starts off with, some of these are environmental variables and some of them are not, so just kind of go through and all this stuff. And then there's where we kind of sort of left off there, and there's some more stuff, and here's a bunch of other weird stuff and lots of weird stuff, and here's some functions, and just it goes on and on and on and on and on. Yes, there's programming inside here. Yes, there's programming. I'm going to hit Q because I'm done. So, while read minus R, keep. These are functions that you type. So for example, when we did the man command, and I type in something that does not exist, like kumquat, it says no manual entry for kumquat. But if I type something in that does exist but does not yet have installed, I'm going to use mtools as an example. It comes, oh, well, that's weird. Huh, okay, I was expecting that to come back and say, we don't have this, but we could get it for you, kind of thing. Anyway, that is what I was trying to show you, is a function that's buried in all this stuff that you can't read. Okay. So what kind of error message do you think you'd get if you ask for a variable that does not exist? For example, I know there is nothing called kumquat. So if I said echo kumquat, what do you think is going to happen? Nothing. There's no error. It just doesn't show you anything. Okay? So it's perfectly okay to ask for a variable that does not exist. It is not an error condition. Okay? Now we talked about aliases one time before. This is a list of aliases. Like for example, when we type ls, we're actually getting ls with the color map turned on. Okay? Because it's kind of cool in our environment to see, like, you know, the directories are in green and executables are in blue, and all those kinds of things. So that's an alias. So when we type an ls, it's actually running an alias ls version. Kind of makes sense? We remember all that? So let's look at some of the more interesting environmental variables. If you look at table 11.1, they talk about the home environmental variable. That one's pretty straightforward. It's where your home directory is. So when I type cd, that's where it's going to go. The next one is the path. The path is kind of complex. When I type ls, and okay, there might be two versions of ls. There might be one in user bin and one in bin. So which one do I get? Well, the path tells you the order in which we're going to look to find the commands you type. So you type ls, it's going to look at the path variable and look at the first one. Nope, it ain't there. Go to the second one. Nope, 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 nope. So the paths could be kind of long. I mean, because there could be lots of things get thrown on here. For example, if you added more software, this could just grow and grow and grow. But right now, I'm going to look in local sbin for local things. Local basically means it's not really part of the package deal. This is something that like you've installed or you've added onto the system, like not factory stuff. So local bin, local sbin, local bin, and then user bin, and then user s. I can't say it. User sbin, and then sbin and user bin, and then games and local games and whatever snap bin is. Snap bin sounds like a snap beans. Okay, so the path basically means look in all these things one at a time, and it's separated by colons. PWD, that's pretty straightforward. That's going to be the working directory, and the user, of course, is going to be you. Now, startup files. Okay. If I wanted to look at what happens when I log in, for example, where the heck is, where's my umask for me? Okay. So if I do ls-al in my home directory, see where there's a .bash rc file? Okay. And there's a .profile. Okay. I'm going to go look at the profile. So I'm going to just type less.profile. Okay, so .profile is going to say, okay, what if I'm running bash, do this. No, if I'm running bash, go get the bash command and do it. And set my path in case the path is not correct. Set my home in case my home is not correct. Okay, kind of makes sense. So let's do that again for bash rc. Bash rc. Okay, so here's the history control. Remember how we talked about how I could have the history always continue or have a limit? Like in this case, the limit is 1,000 entries. Kind of cool. Okay, we're coming up on the 15-minute mark. You know what's going on.